In expansion of ideal gases apparatus model TH172, after completing 2 experiments which refers to Boyle's law, let's get started with our third experiment which refers to Gay-Lussac's law. Gay-Lussac's law states that pressure is directly proportional to the temperature, and here the volume will remain constant. It means mathematically P1 upon T1 is equals to P2 upon T2. Now for performing these experiments, we will start with first basic explanation how to perform the experiment, what kind of data we will collect, which kind of parameters we will calculate, and how we will plot the graphs and charts with the help of DAQ application. First, as you can see in the Gay-Lussac's law apparatus, we are having first the air heater and the temperature and the pressure sensor. So now by seeing this, we can assume that heater will turn it on and it will increase the temperature inside the glass tank. Now inside the glass tank, we are having air as a medium. You can fill the natural gas or any kind of a gas for the medium, but right now we are performing the experiment on our natural gas. So the constant volume we are having inside the glass tank, which is around 15 liters approx. Now when we turn on the heater with the help of the manual button or with the help of the application also, as we have turned on the compressor and vacuum pump in the Boyle's law experiment, same way here also in the Gay-Lussac experiment we can turn on and turn off the heaters from directly to the software. Now when you turn on the heater with the manually or by the help of the application, the heater will start turn on and it is of around capacity of 1000 watt. So the rate of we can say is around 2 to 3 degrees Celsius in every 30 seconds. Here we are having a temperature controller, which I have already explained. The priority of this temperature controller is to set the maximum temperature you want for the safety purpose. Now for the safety purpose, I have already taken the temperature of around 100 degrees Celsius, set it, and also you can set with the help of this keypads 100 degree, 120 degree, 130 examples, etc. This way, after performing this experiment, you can say this temperature controller setting value, we will go to turn on the software. After turning on the software, all the data of temperature and pressure is collecting inside this application, or you can say DAQ software, and it is directly storing the data in the Excel sheet as same as a Boyle's law experiment. When the temperature is increasing, the pressure inside the tank is also increasing. It states that temperature is directly proportional to pressure and pressure is directly proportional to the temperature. Volume will remain constant because their volume is changing because the oil is coming and going. Here there is no outlet or inlet for this glass tank. Only air which is situated inside is a natural air and it is our medium. So it is at a constant volume. When the temperature of the heater will increase, the pressure will increase. When the temperature it will decrease, pressure also decrease. How we will state it? With the help of our DAQ model. Now before performing the experiment, we have to perform two types of experiments here. One that is for temperature increasing rate and second one that is for the temperature decreasing rate. So let's get started with the performance of the experiment. First, what we have to do, run the application. I will write it down the name as test 03 because our test 1 and test 2 is of Boyle's law. Test 03, today's date. Now currently, as you can see here, our temperature inside this glass tank is around 31.3 degrees Celsius and our pressure which is inside the glass tank of air is around 0.0 bar. It means at 30 degrees Celsius ambient, our pressure is at 0.0 bar inside this tank, not in an environment. In our environment, it is around 1.013 bar, but we have already performed so much of experiments inside this. So we have set it around 31 degrees Celsius and 0 bar pressure. Now let's get started by switching on the heater. You can turn it on with the help of this manual or directly from the application part. I will go from the application part. One toggle switch is there. By turning it on, our electric circuit is on and the heater is on, as the indication is here. Our red LED heater is on. Now wait for few minutes, or you can say 5 minutes or 6 minutes. Our observation is already started. 32 observations till now already we have collected, but it will take some time for the heating, so we have to wait for around 2 to 3 minutes for temperature rising rate. As now we are having, you can see already the temperature rising rate has started. The previous temperature at the starting before turning on the heater, we are having around 31 degrees Celsius. Now our temperature is around 32.75 degree and our pressure is around 0.03 bar. So as you can see, at 30 degrees Celsius our pressure is 0, but right now at 33 degrees Celsius our pressure is 0.05 bar. It means as the temperature is increasing, our pressure is also increasing. But as you can see here, our graph is also plotting. The graph will be linear. X side we are having pressure in the bar unit, on the Y side we are having temperature in degrees Celsius. So our graph should be always linear, because whenever the temperature will increase, our pressure will also increase. This graph is also collecting the real-time data. Now after around 30 seconds we are having a temperature of around 39 degrees Celsius inside this glass tank and pressure of around 0.1 bar. So as you can see, in 30 or 40 seconds after waiting, the heating is started and around 40 degrees Celsius it is showing you our 0.1 bar. Now we have already collected around 76 observation. We will wait until our maximum temperature, which is at 100 degrees Celsius. We will see that it actually cuts the heater circuit or not. So it is around like 46 degrees Celsius. We will wait for around some few moments until it reaches the maximum temperature, and we will see at maximum temperature it should cut off the electric signal. Temperature is around 60 degrees Celsius and graph is also showing the linear way. Pressure increasing, temperature increasing. So our first experiment is going successfully, like our temperature is also increasing and our pressure is also increasing. Now around 70 degrees Celsius pressure is showing around 0.18 bar. So as you can see, at the start of experiment at 30 degrees Celsius 0 bar, right now after 1 minute 70 degrees Celsius 0.18 bar. So the graph is already plotting, the real time data is already collecting inside our Excel sheet. So 90 degrees 0.2 bar. So with the help of this data, we can directly state that Gay-Lussac law, temperature is directly proportional to the pressure. And with the help of this graph also, we are collecting the real time data. Now 96 degree, 97 degree, and here we have to see 99 degree, and at 100 degree our heater is cut off. It means our heater is off now. Now after some time the heater signal, or you can say now already it is cut off, but some amount of air is inside it which will be heating up and it will showing you the temperature right now 110 degree 0.2 bar. After already we have cutted the heater power off. Now I will switch off the heater from application part, because I have already done with the application. I have already switched it off the heater part, and successfully we have collected around 150 observations. In 3 to 4 minutes we have collected around 150 observations that we can see inside the Excel sheet. Like, I will stop this experiment. After stopping this experiment, directly I will go to my test results, that is test 03, and today's date. I will open this folder, and in this Excel sheet we will see all 150 observations with date, time in details. Now as I will show you, in 15:06 time 4:19 our observation 1 is P2 bar, because this data is refers to pressure number 2 and temperature number 2. Our boils refers to our pressure number 1, temperature 1. So our pressure 2 and temperature 2. T2 is around 31 degrees Celsius in observation 1. P2 is around 0 bar approx. And after completing this experiment, around 150 observation we are having. Temperature around 120 degrees Celsius, 127 degrees Celsius. The pressure is at 0.23 bar. So now here inside the pressure is at 0.23 bar. If you want to see actual pressure, what I will do, I will release the pressure right now with the help of this knob. Now you can see the pressure is inside, is already releasing inside the environment. So if I will check the pressure inside right now, it will be 0, or you can say the atmospheric pressure. So like this way, all the Excel sheet data we have already collected with the help of our linear graph is also shown in the real time. This way we have completed our experiment number 3 on the Gay-Lussac law for the expansion of ideal gases successfully. In expansion of ideal gases apparatus model TH172, we will proceed with our fourth experiment with the Gay-Lussac's law. Now in the fourth experiment we have to perform the same experiment number 3 but in a vice versa experiment. Like first already we have done the temperature rise up to 100 degrees Celsius with the help of this heater on. Now what we have to do, we have to decrease the temperature. Now whenever we will decrease the temperature, pressure should also decrease. Now for certain heating, I have just turned on our heater manually. Our heater is on. It will reach around 100 degrees Celsius at our maximum settable temperature controller temperature. After that we will perform the experiment. Now before performing this experiment, same way what we have to do, in our application I will run the application. I will store this data as test last experiment 04, today's date. Now we have to do the experiment in this. We will decrease the temperature. Now for decreasing the temperature, just what we have to do, we have to wait and watch the temperature readings and the pressure reading in the application. As you see, heater is off, our temperature is around 100 degrees Celsius and our pressure is at 0.12 bar. Now after certain time, as the temperature decrease, why temperature will decrease? Because we have already cut off the signal, electric signal to our heater. It means the air volume inside it, which is at a temperature of 100 degree, which is at a temperature pressure of around 0.13 bar, will again coming down, or we can say cooling, because the heater is turned off. Now our temperature is around 104.9 degrees Celsius, is around 105 degrees Celsius, and our pressure is at 0.12 or 13 bar. Now wait until the temperature will reduce and we have to see the linear graph which is coming downwards. In the experiment number 3, Gay-Lussac law, in the heating application the graph is going linear on the upside direction. In the last experiment number 4, which is vice versa or reverse experiment, you can see when we are cooling it, the linear graph will coming down. On the x-axis we are having a pressure with the unit of bar, on the y-axis we are having a temperature with the unit of degree Celsius. Now we have to wait and watch the temperature at the time when the temperature will going down. At that time we have to start taking the readings. Already I have started the application. We have collected around 50 or 60 observations. Now temperature is settled down at around 108 degrees Celsius and pressure is around 0.12 bar. Slowly it will decrease the temperature because heat output is 0 right now because our heater is turned off. As you can see here, now our temperature is 107 and pressure is 0.1172 bar. So now the cooling has initiated. It will take some 30 or 40 seconds because already inside the heated air is there, so it will take some time for cooling down. So we have to wait until 2 or 3 minutes for cooling down rate. As the temperature is now decreasing, you can say 100 degrees Celsius, our pressure is 0.10. It starts now decreasing. We will wait until 30 to 40 seconds for continuous down rate. So as you can see, whenever the graph is going down linearly, it's coming down because whenever the temperature is decreasing, pressure is also decreasing. So Gay-Lussac's law states that inside volume should remain constant, which is already at a constant, and temperature will decreasing, same way our pressure is decreasing. Now our temperature is at around 103 degrees Celsius in our application and the pressure is 0.092. So from 0.099 it's coming 0.92, 102 degrees Celsius 0.097. okay. So now this way, it's after 2 or 3 minutes it will coming slowly it is cooling because heating rate is faster because it is having some electric signal. A cooling rate is very slowly, it will take 10 to 15 minutes for coming to the ambient temperature because it is already closely packed, no air is going inside, already heated air is inside there, and it will take some time for the cooling. So like this way, after completing our fourth experiment with the collecting data in the Excel sheet, we have seen as the temperature is decreasing and the pressure is also decreasing, it states that our fourth experiment, temperature is directly proportional to the pressure at a constant volume. And in the same way, Boyle's law and Gay-Lussac's law, all the experiment, 4 experiments successfully we have completed, and with the help of the DAQ, Scitech DAQ application software, all data you can collect inside the Excel sheets, each and every experiment individually, and for the future process we can see it for the plotting the graphs and plotting charts.